Welcome students in the video mixture part 3. Here we will discuss methods of separating mixtures. In this video we will talk about methods of separation. We have 4 types of methods: separation of solids from a mixture of solids, separation of insoluble solids from liquid, third, separation of soluble solids from liquids, and fourth, magnetic separation. In this video, we will talk about the first one, separation of solids from a mixture of solids. But before we begin with it, let's understand what is the need for separation of a mixture. First one, to obtain two different but useful components of a mixture. Example, butter is a useful component which is separated from milk by churning. Second, to remove harmful components or impurities from a mixture. Example, small pieces of stones and husk are separated from rice or dal before cooking. Third, to remove useless components of a mixture. Example, tea granules are separated from tea. In the mixture part 2 video, we discussed under methods of separation part 1, separation of solids from a mixture of solids like threshing, winnowing, hand picking, sieving and sublimation. In this video, we will deal with separation of insoluble solids from liquid, separation of soluble solids from liquids and magnetic separation. Under separation of insoluble solids from liquid, we will talk about the solute, that is solid, does not dissolve in liquid. We have got 3 methods to separate the solute, the insoluble solid from the liquid which does not dissolve. First one is sedimentation, second is decantation and third one is filtration. Let's understand all 3. The sedimentation means when the heavier component in a mixture settles after water is added to it. The process is called sedimentation. When the insoluble solute is mixed with solvent, it does not dissolve, they do not mix together, and the heavier component of that solute particles, they settle down at the bottom of the vessel. That is called the sedimentation. Decantation, when the water is removed, avoiding the sediment, the process is called the decantation. That means when we tilt the vessel and remove the water or the solvent, that process is called decantation. Filtration, it is a process of separation using some filter like strainer is called a filtration, where a filter paper is used or some filter like strainers are used to separate the insoluble solids from the liquid. That process is called the filtration. Let's take each of them separately. Sedimentation, it is the process by which the insoluble heavy solid particles settle down their own in a solution. In order to separate the two, the liquid has to be gently poured into another container without disturbing the sediments. Here we have got 2 vessels. In the first one, we add sand in the water and then we allow it to rest for some time. What do we observe? We observe that the particles, the sand particles, heavy and the coarse ones, they all settle down at the bottom of the vessel. Now, once we observe the vessel, what do we find? We find that the heavy particles, they have settled at the bottom, whereas in the middle we can still see some muddy water, and at the top layer of the water we can see some clear water. So the sedimentation means where the insoluble particles, they settle down their own, that is because of their gravity pull, they settle at the bottom of the vessel. So this is called sedimentation. Decantation, decantation is done to separate particulates from a liquid by allowing the solids to settle to the bottom of the mixture and pouring off the particle free part of the liquid. Another method is to allow 2 immiscible liquids to separate and the lighter liquid is poured off. Immiscible means incapable of mixing, like water and oil. Oil and water, they both are liquid but they do not mix together. We can see the separate layers of both oil and water. So, in such conditions too, decantation process is used. So, decantation is used when we tilt the vessel and pour off the free particle of the free part of the liquid into another vessel. Examples of sedimentation and decantation. The mixture of sand and water is taken in a beaker and allowed to stand for some time. The sand, being heavier than water and insoluble in water, settles at the bottom of the beaker. This settling down of the particles in lower part of the container is called sedimentation. Then take another beaker and put a glass rod in a slanting position. Slowly take the first beaker and pour the water gently on the glass rod. This transfer of water is called decantation. Now, on page number 43, activity number 10, we have to separate the mixture of insoluble solids in liquids by sedimentation and decantation. Instead of just sand and water, we have taken in this activity sand and water, rice and water, and then dal and water. So, we have taken 3 test tubes and the solute or the insoluble solids are sand, rice and dal. Now, rice and dal, they also weigh. They are heavier than water. What will be the result? So, when we mix sand, rice and dal in 3 test tubes containing the water, and once we observe them, what will we see? We will see that sand, rice and dal, they all have settled down in the respective test tubes. They are separated from water by slowly tilting the test tubes. So, when they settle down at the bottom of the water, that process is called the sedimentation. And then when we slowly tilt the test tube to remove or to separate the water, that process is called the decantation. The water obtained by separating the mixture of sand and water is not absolutely clear. Why? Because we get the muddy water. The sands are not very heavy. So, because of that, they do not clearly settle down at the bottom of the vessel or the test tube. Small particles of the sand can be seen floating in it. But it is not a case with dal and rice. Dal and rice, being very heavy than the water, they settle at the bottom of the test tube and the water can easily be drained out of that test tube by the process decantation. Filtration. It is a method of separating insoluble solids components from a liquid by passing them through a suitable filter. That is, where a solid is not dissolved in the solvent. The substance that remains in the filter is called the residue, and the substance that flows through the filter paper is called the filtrate. So, we use filtration to separate smaller particles from a liquid or gas. A filter is used to catch the particles but allows the liquid to pass. Activity number 11, where we have to separate a mixture of sand and water. The materials required are a filter paper, a funnel, 2 beakers, an iron stand, a glass rod, sand and water. So, we take a filter paper and place it in a funnel after making its cone. Set up the apparatus as shown. Now we pour the mixture containing the sand and water over the filter paper using the glass rod. Now what do we observe? We observe that clear water gets collected in the beaker, kept below the funnel, and the sand remains in the filter paper. A mixture of sand and water can be separated by using a filter paper. So, filtration is used to separate an insoluble solid from a liquid, where we have used a filter paper or a convenient or suitable filter. Now, in our opinion, which one is better method of separating sand from water? Sedimentation and decantation, which we read earlier, or this filtration, and why? Well, filtration is better because during decantation, after the sedimentation occurs, and then when we try to tilt the beaker or the vessel to remove the water, there is a chance of particles mixing back in the liquid, whereas in the filtration we can overcome by this because we have used the filter paper. So filtration is better than sedimentation and decantation. Let's revise. Separation of insoluble solids from liquids, that is, the solute does not dissolve and mixes completely with the liquids. We can still see the solids remain in the liquid, and the processes are sedimentation and decantation and filtration. Sedimentation and decantation go together. Sedimentation is the process in which insoluble impurities settle at the bottom of the liquid to form sediment. Example, obtaining clear water from muddy water. In the sedimentation process, the sand or the solute or the solid particles, they settle down at the bottom of the beaker or the vessel, and then the water which remains upward or the upper portion of the beaker or the vessel can be removed. After the settling of the impurities, decantation is the process of gently pouring clear liquid into another beaker without disturbing the sediments. The decantation process takes place where we tilt is jhukana. So we tilt the vessel and we pour off the liquid into another vessel. Another method is filtration, where we read we use the filter paper or a suitable filter to contain or to the residue to remain in the filter so that the residue and the liquid can be separated. In the filtration, it is the process by which very fine insoluble solids can be separated from a liquid solid mixture by passing it through a suitable porous material like filter paper. The liquid obtained after filtration is called the filtrate, and the leftover, the substance that remains in the filter, is called the residue. Example, tea is filtered using a strainer. Earlier we read separation of insoluble solids from liquid, that is, the solid do not dissolve or mixes completely with the liquid. But what happens when the solute or the solids, it mixes completely or it dissolves completely in the liquid? Well, the process is called the evaporation. Evaporation is a process in which a liquid changes into gaseous form on heating, allowing the liquid to evaporate, leaving the soluble solid behind. There are many solids that dissolve in water completely, like salt and sugar dissolve completely in water. In order to separate salt or sugar from water, we use a method called evaporation. Activity number 12 on page number 44, where evaporation is used to separate sodium chloride from a mixture of sodium chloride in water. Sodium chloride is salt. So here we take water in a china dish and we add a teaspoon of salt in it. We mix it together and salt mixes completely, it dissolves completely in the water. Now we cannot use sedimentation and decantation because it has been dissolved completely, nor we can use filtration. So we need to evaporate, the process evaporation. So what do we observe? The water evaporates and salt is left in the china dish. So we conclude that salt can be separated from a mixture of salt and water by evaporation. So basically, when the mixture of sodium chloride and water is heated, the water particles stir from a liquid to a gas and then escapes from the beaker, and the leftover, the residue which is left behind after the evaporation, is salt or the sodium chloride. We know that iron gets attracted by a magnet. A magnet can be used to separate a magnetic substance from a non-magnetic substance. Magnets are used in the recycling industry to separate ferrous, that is the iron, and non-ferrous metals. Ferrous means iron. Magnetism. Some substances are attracted by magnet field and can be pulled from a mixture. The method of separating components of a mixture by using a magnet is called the magnetic separation. Separation by magnetic attraction uses magnet to separate magnetic material from non-magnetic material. Like if we have a mixture of iron and sand, we know that iron is magnetic object. Iron is attracted to the magnet, whereas sand is non-magnetic object. It is not attracted towards the magnet. Examples of magnetic materials are iron, nickel, steel. Examples of non-magnetic materials are copper, gold and silver. Magnetic separation is used in mining industry and in junkyard. In the mining industries, it is used to separate iron from non-magnetic materials. In the junkyard, it is used to separate steel, that is a reusable metal, from the scrap yards. So, if we have a mixture of sand and iron filling and we hover a magnet over the surface of the mixture, what do we observe? We observe that the magnet attracts the iron filings, leaving the sand in the trough or the vessel. Magnet attracts certain type of metals, for example, iron and nickel. We can use magnetic separation if we want to separate mixtures that consist of magnetic material and substances that are non-magnetic. We may have a mixture of sand, sawdust and salt which can be separated by using winnowing, filtration and evaporation. That is where we have a mixture of many components, we sometimes need to use many methods to separate them. So, here sawdust is separated from other two constituents by winnowing. As sand is insoluble and salt is soluble in water, sand is separated by dissolving the mixture in water and then filtering it. Now, salt remains dissolved in water, which is obtained by evaporating water. Second case, the constituent of a mixture of iron filings, sulfur and common salt can be separated by using magnetic separation, sedimentation and filtration and then evaporation. How does it go? Where we have iron filing mixture with sulfur and common salt, iron filings are separated from the mixture by magnetic separation method, as iron is magnetic substance and other two are non-magnetic substances. Sulfur is insoluble in water, so we will use the techniques which are used for insoluble solids, that is filtration and decantation or sedimentation, these three, any of them. So, here sulfur is insoluble in water while salt is soluble in water. Therefore, sulfur is separated by dissolving the mixture in water and then filtering it, that is decantation. Now, salt remains dissolved in water. Salt is completely dissolved, and for such cases where we have the soluble solids from liquids, we use evaporation. So, sometimes to separate the constituent from a mixture, we might have to use multiple methods to separate the constituents.